Hello, welcome to your OPS 245 week 9 video. This week we're looking at LVM, Logical Volume Management. So LVM gives you flexibility to manage your file systems and modify them, specifically modify them while they're running. You can add partitions to volumes. You can expand them. You can do all kinds of cool stuff. So it's used to manage your physical data storage in your partitions in Linux and Unix. And it gives you a lot more flexibility than just partitioning. It allows you to create complex storage schemes and grow your file systems as needed. A single disk with LVM can span multiple physical disks, but be represented as a single physical file system, which is great. You need to add more storage to a server. You don't need to format it or anything. You just add another hard drive, and with real servers, they're hot swappable usually, right? So you just add more storage. You're good to go. And when we're talking about LVM, there's a couple different terms that come up. Physical volumes are disks and partitions. Volume groups is your storage area or your pool of storage that could be added to or moved to any way. And then logical volumes are the different mount points relating to the space from a volume mounted in the file system. You can think of these as kind of like virtual disks. Hopefully that makes sense. So physical volumes refer to disks, any disks that are physical or virtual, and any partitions that you've created. LVM classifies disks and partitions under a single term, but keep in mind that a disk or a partition isn't considered anything according to LVM until it's been initialized as an LVM physical volume. So volume groups are basically a pool of physical volumes that are combined and made available as a single storage unit. When physical volumes are added to the group, the combined storage capacity of all the disks is made available to all the systems as a single pool, which is actually pretty cool. Logical volumes are software-defined virtual partitions. Logical volumes are assigned a specific amount of space from your volume group. It can be formatted and mounted on the system. And like a partition, it could be used for a particular mount point, like, for example, home. Now there's two main advantages to using logical volumes over standard partitioning. You can have more complex schemes, so you can have your volume spanned over multiple physical disks, and you can grow or shrink these or even move them to other disks as hardware fails relatively easy. And all of the concepts that we're talking about here translate to the cloud oh so well. They really do. Now when we're working with this in CentOS, which itself is deprecated, it says there used to be a graphical version and it's been deprecated. We're going to do it using the command line. And honestly, that's the way to learn how to do things, because that doesn't change a huge amount usually. And in this week's lab, you're going to be working with CentOS 2 and CentOS 3, so that's kind of all we got anyway, right? There's no GUI on those two. Now, before you make any changes to your virtual machine's file system, you have to know how it's configured. So you can use a few commands, some that we've looked at, such as df, which shows the disk amount of free space on the disk. We saw this last week. lsblk, which lists block devices. ssmlist, System Storage Manager. You have to install that. PVS, which shows your physical volumes. LVS, which shows your logical volumes, and it's cut off at the bottom of the slide, but VGS, which shows your volume groups. All of these will require root access, so you need to stick sudo in front of those. File systems themselves reside on specially formatted files called block devices, and these are all stored in dev from root. The first SATA, PATA, SAS, SCSI, or USB attached hard drive is SDA, then SDB, then SDC, and so on and so forth, and that name's used to represent the entire drive. And then you can have partitions and physical volumes on those drives, which are numbered starting with 1. So SDA1, SDA2, SDB1, SDB2, and so on and so forth. Virtualized disks use VD as the prefix, but the whole rest of it works exactly the same. VDA1, VDA2, VDA3, VDA2 to represent the actual attached virtual drive. You might see other letters out there. There are a few others that are used, but these are the only two we're going to work with. And you might see one, you might see the other. When you're working through the lab, you're going to have to look at what's used and what's available on your system, and you might have to modify the command accordingly to work with what you've got. Now, before you can do anything with it, those devices have to be physical volumes. So you're going to use fdisk to format the disk and create the partition, pvcreate to create a physical volume, so pvcreate and then the path to the device. That's the way that one works. And then once you have them, you can add them to a volume or create a new one. To add them to a volume, just vg extend, the name of the volume group, the name of the physical volume that you want added to that group. To create a new one, similar syntax, vgcreate, the name of the volume group, and the name of the physical volume you want added to it, or added to it, to exist within it. Volume groups can have more than one physical volume, but they should have at least one. Now, sometimes you might want to remove a physical volume because you want to reallocate that disk space somewhere else in the file system. You can do that using the vgreduce command, which the syntax is vgreduce volume group block device. And this only works if the volume group still has enough space for all of its logical volumes without that. If it's not going to have enough space, it won't let you do it. So now that you've got storage available in your volume group, you can divide it up into one or more logical volumes. You can create a new logical volume by using lvcreate --size and give it a size and a unit so it knows how that is measured, -n and a name, and then the volume group that you want it added to. So for example, lvcreate --size 2g will create a new volume that's 2 gigs. -n, we're giving it the name archive in this example, and it's being added to the volume group CentOS, created CentOS _ CentOS 2. Hopefully that makes sense so far. And we're going through these slides pretty quick. This is probably going to be a fairly short video, which is hopefully good news. Now once you've got your logical volume, it's ready to use for the most part, except you have to format it. So you're going to use the mkfs command for that, -t, specify the type, and then the path to the logical volume. Now that type could be ext4, it could be xfs, could be any file system type, and we dealt with a bunch of file system types in Lab 2. The logical volume is the path to the logical volume that you are creating in the file system. So it's a combination of the path to the volume group, and the name of the logical volume usually starts with /dev, but not always. Now once you've got a logical volume, you want to resize or reduce them, right? Or extend them. Resize, reduce, or extend. There's three options here. Resize will allow you to reduce it or extend it. Reduce will only allow you to reduce it. Extend will only allow you to extend it. And here's your syntax for all three of them. LV, either reduce, resize, or extend, -R, -- and then the size. If you're using reduce, minus, so we're making it smaller, right? Extend, a plus, we're making it bigger. Resize takes both, then your size and your unit and your logical volume. You need to put those in, or you should put those in. If you don't put them in, then you're actually just resizing it to a static size, which could be useful. Just saying. And the other two, reduce and extend. If you try to expand a disk with reduce, or reduce the size of a disk with extend, they're going to fail because you're not using the command correctly. So now that we have volumes, right? We've formatted them, we've partitioned them, we've done all of that fun stuff. We need to manage them somehow. They're all automatically, for the most part, mounted in boot, or mounted on boot in Linux. And that's done by looking at a file in etc. You know it's important because it's in the etc directory, fstab, which is short for file system table. And you can look at that file yourself if you want. You can modify it and manually add or remove volumes. Be careful when you're messing around with this file, and you're going to mess around with this in the lab this week, because if you have a syntax error in here, it might cause your system to not boot. So just be careful. If you're going to remove something, you might want to comment it out with a £sign at the very beginning of the line, just in case you want to add it later. And you edit this file with any text editor. You could use Vi, you could use Nano. You're going to need root privileges, so stick sudo in front of that, you're good to go. Every line in there represents one volume to mount, and where you want it mounted in your system, along with a few other options. So we have our volume, that's the identifier for the mount, so the path to the logical volume. The mount point, where you want it mounted or attached to. The file system type, so that's ext4, XFS, swap, etc. Options to be included with mounting. You can make it read-only, you can make it mountable only by certain users. We're just going to leave it as defaults because, well, that's what we're going to do. And then the two numbers at the end are backup and sequence. Backup could be a 1 or a 0. It tells the system to include it or not when it's being backed up. And that's used by tools that we're not using in this course, so you don't need to worry about it too much. You might need to worry about it later, but not in this course. Now sequence, that's the order in which to perform file system checks on it when booting. 0 means don't, 1 means do it first, 2 means do it second, so on and so forth. So we've got an entry here. I'm going to kind of ignore the one at the top. Dev CentOS _ CentOS2 archive, that's the volume that we're mounting, right? Now where are we going to mount that? We're going to mount it to archive. It's got a slash in front of those. They should all be absolute paths, right? It's got a slash in front of it, so that indicates that this is from root. This exists in root. Its file system type is ext4. We're going to use the defaults for mounting options. It should be included in backups when backing up the system, and we're going to check it second when, well, the file system is going to check it second when booting. That's what it means. Kind of handy. Now, for a file system to be available, it has to be mounted. A mount point, it's just like a directory. Ideally, when you're mounting file systems, they should be mounted to an empty directory, because if you mount it with a directory that has contents in it, that stuff is going to be unavailable in the file system until it's unmounted. It's not deleted, it's just not going to be accessible. Some file systems are automatically mounted, some aren't. There's different ways you can do this, not just using FSTab as well. But we're only going to use FSTab. Just throwing it out there. Anytime you make a change to etc FSTab, you could reboot, or you could just use mount-a, and that will attempt to mount all the file systems listed in it. And you should probably do that before you reboot, because if there's errors in that file, mount-a will let you know. And if there's errors in that file, and you reboot, then you might not be able to boot your system up. You might end up in a recovery shell, and then you gotta recover and fix things from there. So test it out with mount-a. Save yourself some headaches. It's worthwhile. We're just flying through these slides. This is going to be a quick video. Now, aside from using mount-a, you might want to mount or unmount a single volume on your own instead of at boot time, and you can do that. You just specify the device path name. So mount/dev/VDA3, for example, would mount that partition. You need root permissions for that, so stick sudo in front of it, or have issued sudo-i, so your root until you type exit. umount will unmount it. And doing this with these commands isn't persistent. So when you restart the system, it's not going to be mounted or unmounted. That's why you do that in etc FSTab in the file system table. When you're expanding storage, you should work from the outside in. So make your physical volume first, then add it to the volume group, and then expand the logical volume. When you're shrinking storage, you should do the reverse, work inside out. So shrink the logical volume first, then shrink the volume group, and then remove the physical volume. If you mess with that too much or deter from that, it might not work. It's just a good idea. So all of this should help you finish up Lab 5, which we're going to work on this week. And yeah. So just a quick reminder, since I'm recording this on Sunday night, and you might see it before then, you might not. We actually don't have a quiz from last week, so that's great. We do have a quiz this week that should be available now and is available until next Monday, the 17th at 11:59 p.m. and that covers Lab 4. Next week we're going to have Quiz 5, and next week we're going to release and look at Assignment 2, so that gives you a few weeks to work on that. That seems crazy, Assignment 2 already. So this week, finish up Lab 5 in the lab. The Python in Lab 5 worked no problem out of the box. And Quiz 4. It's not so bad. Another really short lecture video, which it's kind of a shame we're not in class, because this would give you a lot more time in class to work on things. Kind of sucks that we're not in class. On that note, take care, be safe, have a great week, and we'll see you in this week's class. Bye for now.